Good morning, my students. Our lesson today is probability. We have learned before the theoretical and experimental probability. Experimental probability depends on experiments and results of a survey. Anyway, the probability of an event is described by the ratio. The probability of an event equals number of outcomes in the event over number of all possible outcomes in the sample space. Theoretical probability is based on the assumption that all outcomes in the sample space occur randomly, which means all possible outcomes are equally likely. For example, number 1, tossing a regular coin. There are two possible ways the coin can land, head or tail. Each way has the same chance of happening. The chances of head and tail are equally likely. Number 2, rolling a regular die and observing the number on the upper face. Each number had the same chance of occurring. The chances of all numbers are equally likely. A random experiment is an experiment where its all possible outcomes are known before simulating it, but we can't determine the actual outcome. Sample space is the set of all possible outcomes of a random experiment. The number of its elements is denoted by n of s. An event is a subset of the sample space. If A is an event in S, then A subset to S. And the number of elements in A is denoted by n of A and is the number of outcomes in the event A. Then, probability of occurring an event A subset to S is denoted by B of A, where B of A equals number of outcomes in the event A over number of all possible outcomes in the sample space, equals n of A over n of S. Since n of A less than or equal n of S, so number of events over number of sample less than or equal 1. Since n of A belongs to n of S belongs to Z positive, then n of A over n of S more than or equals 0. Since 0 less than or equal n of A over n of S less than or equals 1. So 0 less than or equal probability of an event less than or equals 1. Example 1. A numbered card is selected randomly from a set of similar cards numbered from 1 to 24. Find the probability of getting a card carries a multiple of 4. Sample spaces of letter A is from 1 to 24. So number of sample spaces equals 24. Let A be the event of getting a multiple of 4. Multiple of 4 equals 4, 8, 12, 16, 20, 24. So number of events equals 6. So probability of this event equals 6 over 24, which is quarter. Letter B, find the probability of getting a multiple of 6. P, let P the event of getting a multiple of 6. So B equals set of 6, 12, 18, 24. N of B equals 4. Probability of B equals N of B over N of S, which equals 6. Letter C, a multiple of 4 and 6 together. Let C be the event of getting a multiple of 4 and 6 together. C equals 12, 24. So N of C equals 2. So the probability of letter C equals 1 over 12. Letter D, probability of getting a multiple of 6 or a multiple of 4. So the sample equals set of 4, 8, 12, 16, 20, 24, 6, 18. So N of D equals 8. So the probability equals third. Letter E, find the probability of getting a number divisible by 25. This event is impossible because there isn't any number in the cards divisible by 25. So the probability equals 0. Letter F, find the probability of getting a positive integer less than 25. This event is a certain event because all the numbers in the cards are a positive integer. So the probability equals 1. Refer to the given example. Impossible events. Phi, an event can't be occurred. The probability of an impossible event equals 0. Certain events, an event whose outcomes are all possible outcomes. So the probability of a certain event equals 1. Exercises. Selecting randomly a card out of 40 similar cards in a box numbered from 1 to 40. Find the probability of getting a card carries letter A an even number. Since the even numbers from 1 to 40 are, as shown, its number equals 20, then the probability equals half. Letter B, a number divisible by 3. The number from 1 to 40 which are divisible by 3 are, as shown, their number equals 13. Then the probability equals 13 over 40. Letter C, a number is not divisible by 10. How many numbers not divisible by 10 in these cards? It will be 4 numbers. Then the remaining numbers are not divisible by 10. Their number equals 36. So the probability equals 36 over 40 by simplifying equals 9 over 10. Letter D, a probability of getting a card carries an even number is divisible by 3. The number from 1 to 40 and each of them is even number and divisible by 3 are 6, 12, 18, 24, 30, 36. Their number equals 6. So the probability equals 6 over 40 by simplifying equals 3 over 20. Letter E, find the probability of getting a card carries a prime number less than 20. Since the numbers from 1 to 20 and each of them is a prime number are 2, 3, 5, 7, 11, 13, 17, 19, their number equals 8, so the probability equals fifth. Number 2, drawing a randomly a colored marble out of a box containing 12 red marbles, 18 white marbles, and 12 blue marbles. Find the probability of selecting a white marble. If I select a white marble, it will be 18 over all the number of marbles equals 50. So 18 over 50 equals 9 over 25. Letter B, if I select a red marble, it will be 12 over 15 because red marbles equals 12. By simplifying equals 6 over 25. Letter C, selecting a yellow marble, there isn't any yellow marble, so the probability equals 0. Letter D, non-red marbles, so we add the white and the blue marbles. We subtract the red marbles from the number of all marbles. We get 50 minus 12 equals 19. 19 over 25. Letter E, a red or blue marble. We add the red and the blue marble. We get 12 plus 20 equals 32 over 50. Another exercise. Drawing randomly a colored marble out of a bag containing 32 similar marbles, colored red, white, green, and yellow. The probability of getting a red marble is 3 over 8. Estimate how many red marbles are in the bag. The number of red marbles we make, the probability is given, which is 3/8, times the number of all marbles. It will get the red marbles, which is 12 marbles. The second exercise. A garment factory in the 10th of Ramadan city produced 6,000 units daily. As a sample of 1,000 units examined, 20 defective units were found. Calculate the number of defective units. The probability of defective unit equals 20 over 1000 equals 1 over 50. So the number of defective units equals 1 over 50 times 6000 equals 120 units. Thank you. Goodbye.